right, thank you. So this is what if privacy had an API? So big question that we're going to try to answer essentially in the next 15 minutes or so. So last December, I was at a conference in Paris, the API Days conference, and this is a picture of the API landscape that I took at that conference. So there's literally thousands of different APIs on here, and we essentially have APIs for doing almost anything, sending emails, sending text messages, creating cat memes. But if you look at this, if you could zoom in at all these different quadrants of these different APIs, there's not essentially a quadrant that talks about privacy, talks about data privacy. So why is it that such an important topic of essentially protecting customer data doesn't essentially have a whole spectrum of different APIs that are just normal for us to build against? And I think the reason that we don't have an API for these is essentially it's a really, really difficult problem to solve. And a lot of the reason why I think this problem is so challenging for different companies, despite spending millions of dollars on various cybersecurity tools, we still have all these data breaches. We essentially have a fundamental misunderstanding about how we treat and handle data. And this goes back to all the way back to like 1980s, essentially. And what I like to call this problem is essentially the cheese and the diamond problem. So when it comes to essentially physical objects, like cheese and diamonds in the real world, we understand at a fundamental level that these are different types of objects. Essentially, cheese in your home, you want your guests or family members essentially have access to your cheese so they can enjoy it, perhaps with a cracker. But your diamonds is something different. You don't want just anybody coming in your home and essentially having access to your diamonds if you have diamonds. Maybe because first there's wealth involved, they have more value than your cheese, and then also maybe there's essentially sentimental value because it's an engagement ring or something like that. So you control access to something like a diamond. And we understand that at a fundamental level, but when it comes to data in the digital world, we essentially treat all objects essentially the same. Whether that's a click on the website or a home address, data is essentially just data. But it's very important when it comes to essentially data privacy that we understand that not all data is created equal. Some data, and we're talking about essentially sensitive customer information, things like people's names, date of birth, financial information, healthcare information, all these things require better protection than other forms of data, and these things are special. And because they're special, they need to be treated that way. Just like when it comes to things like my passport or my children's birth certificates. I don't keep those in the junk drawer in my kitchen with my batteries and my flashlights because they represent different things. They have different levels of sensitivity. If someone steals my batteries, it's not that big a deal. I can replace batteries. If someone steals my daughter's birth certificate, then I feel like I failed as a parent. But also the information on her birth certificate, like her name, her date of birth, other information that's there, once it's been compromised, is essentially out forever. Like there's no way to essentially just cancel that and get a new date of birth. So it's very important that we treat this data as something special. But we don't typically do that. We essentially just take all this information and put it in the same place, like a database. And that leads to all kinds of problems. So we can take a look at a simple example here. We have a pretty simple system here. This is an abstraction. Of course, modern systems are much more complicated than this. But when we collect information like someone's phone number, what ends up happening with someone's phone number is we pass it through all these downstream services, and we end up with a copy of it in the database, the data warehouse, the backups of these systems, the replicas of these systems, as well as the log files. And why is this a problem? Well, we end up with this essentially sensitive data sprawl problem, where we end up with thousands of copies of essentially customer information. Imagine if you, instead of having one copy of like your passport that maybe you have in the safe in your hotel room, you created thousands of copies of your passport, and then you put them all over Miami, and you tried to protect those different locations. That's a much harder problem to solve than having essentially one copy that you keep in a safe location. But that's what we do with data, essentially. We create all these copies, and then we try to stitch together different solutions to essentially protecting that information. And that is a very difficult problem to solve, and essentially causes all kinds of challenges. So we essentially stitch together duct tape and chicken wire on top of this existing broken system. It's like putting a Band-Aid on a broken arm, and we expect this to essentially solve the problem. But we're not solving it essentially at a fundamental level. So how do we do that? How do we solve this from essentially a first principles approach? Now, luckily, there has been a few companies like Apple, Google, Netflix, a handful of others, that pioneered essentially this technology or architectural pattern known as a zero trust PII data privacy vault. And what they did was they recognized essentially that customer data is something special. So they treated it that way by moving their customer data out of their existing infrastructure and into these zero trust PII data privacy vaults. And what that does is it creates essentially an isolated, protected, single source of truth of the customer data, similar to having that one copy of your passport in the safe in your hotel room, rather than having thousands of copies of it. And it essentially de-scopes their existing systems from the responsibilities of data security, data privacy, compliance, and so on. So sounds amazing, right? So a data privacy vault essentially isolates, secures, stores, and tightly controls access to manage and use sensitive data. So it's built around this principle of isolation and essentially creating this single source of truth for specially handling essentially your sensitive customer data. So in practice, what that looks like is we take this problematic system that we talked about earlier. When we take the data privacy vault, what we want to do essentially is de-identify sensitive data as early in the life cycle as possible. So when we're collecting something like someone's phone number, we want to essentially treat that differently than we treat regular application data and move it into the vault as early as possible. So now this essentially Pat Smith record only exists within the vault as a single source of truth. And the vault is essentially going to exchange that sensitive data for a token. You can think of it like a pointer or a reference to the original data. So this pointer or reference essentially is de-identified, it's non-sensitive, there's no mathematical connection between the original value and the produced value. It's not like encryption where technically you can reverse engineer it. Essentially ABC123 you can think of as just a random string in this case. So now that we have only non-sensitive data, we can essentially take that, we can pass it downstream, store it in our database, store it in our data warehouse, have it in our log files, and if any of these systems get compromised, essentially you're just dealing with application data and non-sensitive data. So what we've done is we've de-risked this entire surface area from the responsibilities of essentially protecting that data. Because even if those systems get compromised, it's just non-sensitive data. So there's no real value there versus essentially what traditionally is going to be there around all this customer data. So in the movie Back to the Future, they talk about the flux capacitor and essentially how that was the key insight that made time travel possible. And this concept of a data privacy vault, this architectural pattern is essentially what makes building an abstraction layer in terms of an API for privacy possible. And this is what we've been working on at Skyflow for the last 4 years. So we're going to take a look now at sort of the evolution of building an API for privacy. So there's a lot of sort of technical work that needs to go into building a data privacy vault. So when we started, the company essentially spent the first part of building this technology centralized on how do we secure the data? How do we lock this information up? So we pioneered essentially a technology known as polymorphic encryption, which gives you not only encryption at rest and during transit, but over essentially full operations of the data. So encryption in memory, essentially. As well as ways of essentially tokenizing and masking information so you can use it in a variety of different forms. Once we have that, you need things like encryption key management, very important for encryption, auditing services, data governance, authentication, ways of deploying the vault to a variety of different infrastructure setups. And now we need to be able to figure out how do we actually utilize this information? How can we do everything with essentially customer data that we normally do without exposing our systems to that? So how can we execute essentially custom code, process and transform that data all within the secure vault environment, and even share that data with third-party services to send emails, text messages, and whatever else you might want to do with sensitive data. So once we've built up essentially the core of the vault, now we can actually abstract all this through essentially APIs and SDKs. So as an application developer, I don't need to worry about how polymorphic encryption works or how any of this security and privacy tooling works. I can essentially just interact with the REST API. So we don't have time to go into all the various components here, but we're going to dive into how do you control access to sensitive data. So it's one thing to essentially lock data up and throw away the key, but it's not very useful. We store the data so we can use it. So how do we control access to the information, making sure that only the right users essentially have access to it? So imagine we have something like this, where we have a bunch of tokens. Maybe they're stored within your application database. And at some point, you want to detokenize those, essentially exchange those tokens for the original values, perhaps to show like an account screen or something like that in the UI. How do we know that the requester essentially is allowed to see the detokenized values? And that's what I mean by controlling access. So I think the easiest way to do this is to look at a quick demo. So we'll do a live demo here. So here we have a pretty, essentially we have roles across the top. So we have marketing here. And what we've done is we've defined some policies that essentially allow us to control what can marketing see within the vault. So this is all based around the principles of zero trust. So essentially, zero trust means no one or no thing has access until you explicitly give it access. And then through this simple policy language, you can control what rows, columns of information someone can see, and essentially in what format. So in this case, the marketing person can see name, they can see email, they don't need social security number, they don't need to know how old someone is, but maybe they need day and month so they can send them a birthday email each year, and in the case, they also have state. Now, a customer support person, they need access to even less information. So here they have name, last four of social for identity verification, and they can also see a state. But there's also a row level restriction here where the customer support agent can only see customers in the state of Arizona, because maybe that's the only territory that they work in. Or you can imagine creating essentially a policy that restricts access to only the customers that are in the customer support person's queue at any given time. And that way, even in the worst case, customer support agent gets socially engineered to giving up their credentials, like happened a couple of years ago in the Robinhood data breach. Instead of essentially that attacker getting access to 6 million records as they did in the Robinhood case, they'd only have access to maybe 6 records that are in essentially the customer support queue, and you'd have very limited visibility into the actual underlying data in this case, just the name, last four, social, and the state. All right, so that's a very quick introduction to essentially controlling access through this policy language. Now, there are certain circumstances where we want to have more dynamic access to sensitive data. For example, if you're building an application, typically you know who the user is if they're essentially authenticating against whatever your authentication model is. And you might want to use that information to restrict access. Or maybe you have a certain understanding of the relationships between your users, like a teacher having access to student records or a doctor having access to patient records. So how can we essentially take into account application data to dynamically control access to the vault? So in the example I showed, we were restricting access based on a state value. In this case, the example here, we're restricting by California. But if the state value is actually owned by the application, how can we make that information dynamic rather than hard-coded value? So this ID essentially is understood by the application, but not necessarily understood by the vault. So what we did was we introduced something called context-aware authorization, which allows you to essentially create or use a context value, more like a dynamic variable in this case, that can be passed in during the authentication against the vault APIs. So essentially, when I'm creating the JOT token, I can pass in a context value, in this case, in this example, the state, that the application knows about based on my understanding of who the user is. Or another example would be, based on my authentication model, maybe that's auth0, or maybe I roll my own authentication, my understanding of who that user is, I want to restrict their access to only the row of data in the vault that is essentially owned by that particular user. So in this case, I can restrict by person ID that matches the context. And then the way that would work is the front-end application would request a bearer token from the back end. The back end understands who that user is because it's your application. And in this example, we're just going to grab the person ID from application storage. Then we're going to authenticate with that contextual value against the vault. The vault's going to return auth confirmation, return the bearer token, and now we can essentially detokenize the tokens that only relate to essentially that particular user. So in order to essentially compromise or attack this system, you would need the service account key, you need the tokens, you also need to understand what the auth model of the application is, put all that together, plus you can essentially make all this have a short time to live so that the authentication only lives for, say, 15 seconds, long enough for you to make the API call. So all those things would actually have to be aligned, plus essentially do that within the 15-second time window just to compromise a single row of data. So this gets really, really difficult to do. So this whole concept of essentially the data privacy vault shifts the entire conversation of privacy really far left to essentially an architectural decision. And it shifts things from essentially this principle or this idea of privacy by design to privacy by engineering. And as long as we're making essentially this architectural decision to introduce something like a data privacy vault, then suddenly a lot of the challenges around data privacy, data security, compliance, and even things like data residency, which we didn't have time to get into, become as simple as a handful of API calls. All right, so I want to, thank you very much. And I'll be around all day if you have questions. You can also reach out to me on email there and find me on LinkedIn and Twitter and all those usual locations. And if you're interested in topics around privacy and security, you can check out a podcast I host at skyflow.com/podcast, where we dive into various privacy and security related topics and issues, or you can join the community at skyflow.com/community. Thank you.